Have you ever wondered, is the code I'm writing actually fast? So, this is the whole optimization question. Essentially, how it goes and how you should write code is that you write code that works, right? And then you optimize later. But a lot of people tend to like, oh, I'm just going to go ahead and write optimized fast code right off the bat. And then usually what happens is the code doesn't even work in the end, but it's fast, but it doesn't work. So what we're going to do today is just explore this whole concept of benchmarking and timing your code. So here, I am writing a little trading course, right? That's going to come out very soon. And a little bit of advertising here. I'm going to release this trading course, and it'll be it's in Skool, right? You can join my Skool for free right now, and just wait until it comes out, and you get it for free. But when I release it, I'm going to charge money for it. So get on the Skool now. I'll put everything in the description. Okay, let's get back to the meat of this video. So benchmarking, essentially. When you have Python code, right, and you want to know if you're going fast, are you actually going fast or not? A common strategy that you've probably seen before is something like you go import time, right? And then you'd put these two, okay, you'd go like start. Go start equals, time dot time, just like that, right? And then you'd go to the end there, and then just change that to end, yeah? Cool, and then you just print out end start, right? Just like that, easy peasy. Oh, that's refreshing. It's just water. Yeah, and then that's how you would time things. It's not particularly rigorous or anything like that. You're just putting a start and end, and you're printing stuff, right? And then even if you're using Jupyter, I think what you do is like at the start of the cell, you use this like magic command, like it's called time it, and that would time the cell. Yeah, so that's just sort of how timing works there. Oh, we could even run this, see if it runs. Does it run? Yeah, and we get whatever that is in seconds, right? Cool. So I just want to show you a cool, more rigorous way of doing things with pytest and benchmarking, and hopefully you can take this away and use it in your code. So let's go back to the editor here, and this is the course I'm developing. And what I'm doing is I'm making like a header message, right? In trading, you have these messages that get sent across the wire, and this is essentially the header data class. And an important thing you do is you need to decode and encode messages, right? So we're going to benchmark that, right? I'm just going to clear this because it's spoilers. Yeah. So to get things set up, very informal videos. So just, take screenshots and whatnot, or, yeah. So in our dependencies, what we're going to do is we're going to add pytest dash benchmark. And so that is literally just like a pip install pytest dash benchmark, or if you're using UV, which I am really liking these days, you just go UV add. Oh, fuck. UV. Don't worry about that. Not Python. Pytest bench. Yeah, pytest UV add pytest benchmark. Right. Put that in. All is good. All is well. And then you can go to the pytest benchmark and sort of read about, the things you can do. So here are the test paths. How I organize my code is I put the actual like tests, whereby I check if things are working in the tests folder, and then I create a different directory here, another folder called benchmarks, and this is where I put the benchmark test code, right? Which is just all about timing stuff. Cool, yeah, and then that's probably about it. And then just store like the metadata, like the test metadata, this .benchmark hidden folder here. There's nothing in there yet, but we'll get to it. Cool. So let's just run the benchmark, right? So I ran it before, but let's just do this. You can see my command history here. Cool. So what I'm going to run is I'm going to go pytest benchmark only, just benchmark, yep, benchmark, and then whatever thing I wanted to benchmark here. So let's actually look at the benchmark file. So I'm saying benchmark quite a lot. I'm benching the code. Anyway, what am I doing? Yep. So you can sort of split it up into like groups, like encoding and decoding. And here I'm going to benchmark the encoding code, and then literally I just make this header struct, and then I just call the message.encode, and then I sort of put that inside the benchmark function here, and it's all magic. It's all there, you know. There's this benchmark thing here. Anyway, let's run it. See what we get. So it's running it a few times. It's doing its thing. Great. So we get some output here, which is cool. So yeah, it benchmarked decode and encode, right? And what it's saying is these are in microseconds, which is pretty cool for Python. Not too bad. So it's taking like 115 microseconds. So when you're actually doing HFT stuff or like trading and things like that, you actually, so this is the mean. So on average, how long it takes, about 2 microseconds. But when you're building trading systems, the worst part about like if you're in the HFT game, you want to look at some of the worst case or like 4.9s or the the 99.99% percentile and stuff like that, or the worst case, how long things would take, because this is like how long a program would stall before it can like process new messages, right? Which is very important, especially when you're playing that speed game. If there's like a backlog of things there and you need to process, and there's this slow message going, can be quite detrimental. So I look at this, right? How long is the maximum taking here? Cool. So, and you get all like, all this stuff here, and you can, yeah, and so we didn't need to do all that timing thing, and it made this nice little thing here. So what we can do, we can put like different command arguments in here. So let's see what I was playing around. Yeah, so here, I can just move over a little bit. I'll bring it over. Just, that's fine. So we're doing the same thing. We're testing the same file here, but we're putting this argument benchmark save, and we're going to just save a baseline. So we're going to benchmark it and then just sort of record this in some JSON file, right? Cool, let's go. It's going. I'll have a sip of water. Oh, that's good water. That's good. Cool. So it looks like it went a bit faster. I don't know there, but that's cool. So we should have a JSON file here. So if you see 001 baseline, sorry, baseline JSON, right? Now, so and then another thing we can do is we can run the benchmarks again with the what it is. Where is it? You can still, yeah, we go benchmark compare with the baseline, right? And we can run that, but it actually won't compare anything because the naming is a bit funky. So it just ran the benchmark. It didn't really compare anything here, right? It had nothing to compare to. And you can even see this in the errors here, right? It's like pytest benchmark can't compare, no benchmark file, right? It's looking for it's looking for a match baseline, right? And so this tripped me up a bit. I was like, but I saved the baseline. Why are you not comparing? And after a little bit of Googling and stuff like that, you actually need to change the name of this. So it'll, like, every time you do a compare baseline, it'll be like 0001, 0002 baselines. But for this compare thing, it's actually looking for just baseline.json. So we'll change that, right? Hit enter. We'll run the comparison again. Go. Cool. It's comparing, so that looks pretty intense. That's crazy. That's nuts. So yeah, and now we've got a comparison. So it looked at the baseline and it ran the new like benchmark stuff, and it's saying, okay, every time there's red, it got worse, right? Or every time, or like the worst one is in red. Yeah. And that's probably about it. I just wanted to share, like, I thought this was really cool. It was just pytest benchmarks, a little bit more rigorous way of going start timer, end timer. So, I hope this was helpful. And yeah, let me know what crazy things you guys benchmark.